Okay, so hello class again, welcome back. So in this recording, we're gonna take a look at section 3.4, the measure of position and outlier. So, but actually in this recording, I'm gonna do the first half of this section 3.4 then. I will break down the lecture into two recording then, okay. So for this recording, we're gonna talk about the measure of position. So recall that the mean and the median describe the centers of the data, while the variance and then the standard deviation describe the spread of the data. So now in this section or in this recording, we will discuss a precise way to describe the relative position of the values within the entire set of the data. The relative position of the values within the entire set of data. So it's going to help you to determine your position, how good you are compared with the rest of the data sets. So or you might compare your test score, how good is your test score compared with the rest of the entire class. So one of the way that we can show the measure of position is the z-score. The z-score gonna provide you this information, these comparisons. So the z-score provides a way to compare variable with different mean and different standard deviation. Or in general, we can say that the z-score will give you a way to compare variable with different centers and different spread. So what's the z-score? How we calculate the z-scores and what's the interpretation of the z-score? So the z-score represents the distance of a data values is from the mean in terms of the number of standard deviation. Yeah. So the z-scores is show the distance of a data value from the mean in terms of the number of standard deviation. So it's gonna show you how many standard deviation that a data values is above or below the mean. So that's a z-score measure how many standard deviation the data values is above or below the mean. Yeah, so that's gonna be the meanings of the z-score. It's gonna show how many standard deviation data values is above or below the mean. So what's the formula to calculate the z-score? So the z-score is the distance from the mean. So that's why on the numerator, we're gonna take the value minus the mean. And then you want to find out these differences in terms of the standard deviation. That's why we divide the difference by the standard deviation. So we have population z-score with using the population parameter. The z-score equal the x value minus the population mean divided by the population standard deviation. Similar idea, we can replace the population parameter with the sample notation, right? So the sample z-score is equal the value x minus the sample mean x bar divided by the sample standard deviation s. So that's the formula to calculate the z-score. It's gonna show you what is the number, how many standard deviation data values is above or below the mean. So when you do the calculation for the z-score, it doesn't have the unit. The z-score is unitless. It doesn't have the unit for the z-score. It only show you the number of standard deviation data values is above or below the mean. When you have a negative z-score, it indicates that the data values is below the mean. So the negative z-score is going to show that the data values is below the mean. A positive z-score is going to show you that the data values is above the mean. A z-score is typically rounded to decimal place. So most of the time for the calculation for the z-score, we're going to round it to 2 decimal place. Okay, so that's gonna be the definition for the z-score. Once again, we have the notation, the calculation based on the parameters, or we can have the calculation based on statistics. Okay, so let's give it a try with this question then. So you are filling out an application for college. The application requests either your ACT scores or an SAT score. So you have a score of 26 on the ACT. Okay. And then you got 650s on the SAT. On the ACT, the mean, yeah, so on the ACT, the mean test score is 21 with a standard deviation of 4, while the SAT has a means of 514 and a standard deviation of 113. So here's the question. What test score should you provide on your application and why? So should you provide your scores on the ACTs or should you provide your score on the SAT? So you have to see how good you are compared with the rest of the data set, right? So in order to see how good you are compared with the rest, because those are the two different samples, right? Two different population, then you have to calculate the Z-score to see which one is better. So now we're gonna do the ACT first then. Okay, so for the ACTs, and after that, we're gonna do the SAT one. Okay. Now, what do we know from the ACT? So for the ACT, the means is 21 and the standard deviation is 4. Okay, so we know the mean for the ACTs, we know the standard deviation for the ACTs, and you also know the test score for the ACT. Yeah. So we can say that for the mean, we know that the values for the ACT, we know the test values is 26. We know the mean. You can use in the population. Yeah. So the population means equal 21. And the standard deviation equal, do I have it? Yes, I have the notation for standard deviation, which is 4. Okay, so we got everything ready. Now I'm gonna just copy these formulas. I will plug in the values and we work out the calculation. Yeah. So on the numerator, we're gonna take the x value then. So the x value is equal, you have 26. The means is 21. And the standard deviation equal 4. Okay. So let's work out this calculation to find the z-scores of a score of 26 on the ACT. So it's gonna be 26, take away 21, divide the difference by 4. So that's gonna be 1.25. So what's the meaning of this number, this calculation 1.25? So this is a positive 1.25, so which means that when a student with the ACT scores of 26, this test scores is 1.25 standard deviation above the mean. So the test scores of 26 on the ACTs is indicate that it's going to be 1.25 standard deviation above the mean. Now, similar idea, let's give it a try for the SAT one, right? Let's see if you do better on the SATs or not. So the X values or the scores on the SATs is 650. And we know the mean. Do we know the mean? The mean for this SAT will be, what is it, 514. And the standard deviation will be what? And the standard deviation is 113. Okay. Now we got everything for the calculation. Now we're going to copy the formula one more time and we're going to substitute the value so we can work out the calculation then. So the X values is 650 minus the mean is 514. Divide the standard deviation is 113. Okay. Let's use in your calculators and see what's the answer then. So it's going to be 650 minus 514 divided by 113. Okay, so it's going to be about 1.20, right? So it's going to be about 1.20, yeah. So 630, 514, 113. So it's about 1.20, yeah, 1.20. So what's the meaning of this answer then? So the answer is 1.20, which means that it indicates that when a student have the test scores of 650 on the SAT1, that test score is 1.20 standard deviation above the mean. So the ACTs is 1.25 standard deviation above the mean. The SATs is 1.20. So which one is larger? Which one is better? So for the ACT, you go further above the mean, right? So for the SAT, you go not that much. So look like that you did better on the ACT, yeah. So the student should provide the score on the ACT, yeah. So the student should provide the ACT score, yeah. Should provide the ACT score. Since the ACT is 1.25 standard deviation above the mean, it would be better than 1.2. It's further on the positive side of the mean, above the mean, yeah. So this is the calculation for the z-score. This is one of the way that you can show the relative position compared with the rest. Now we have one more practice question. It's still an application of the z-score. Let's see if you can try this one, example number 2. A highly selective boarding school will only admit students who place at least 1.5. So this is going to be at least 1.5 standard deviation above the mean. Okay. On a standardized test that has a means of 200 and the standard deviation of 26. Okay. So we are given that the means is 200 and the standard deviation is 26. What is the minimum test score? Yeah, so what's the minimum score? Yeah, we're looking for the score, right? That an applicant must be made it on the test to be accepted. So let's summarize what we have so far. So we know the mean is 200. So we can say that the mean is 200. Okay. And then the standard deviation is 26. Now, how about the 1.5 standard deviation? So the 1.5 standard deviation above the mean, right? So this is the number of standard deviation above the mean. So once again, what is the number of standard deviation? So the number of standard deviation above the mean is the z-score, right? So now we know in this case, the z-score is equal 1.5. So the z-score is the number of standard deviation above the mean. So they gave you z-scores equal 1.25. Now we're looking for the test score right here. So we're looking for some x value. We know the z-score, we know the mean, we know the standard deviation. So we can use in the previous formula to find out the x values. Yeah. So it's going to be another application of the z-score, but in this case, we find in x. Yeah. So we know the z-score is 1.5. And then on the numerator, we don't know the test score. We know the mean is equal to 200 and the standard deviation equal to 26. It's equal 26. Yeah. Okay, so now this is going to be the algebra equation. Can you guys solve this for x then? So what you're going to do to solve this equation for x? Okay, so we're going to multiply both sides by 26, right? I'm going to say multiply both sides by 26. So on the left-hand side, so I'm going to do 26 times it by 1.5. Similarly, on the right-hand side, I'm going to do 26 times it by x minus 200 divided by 26. Okay. Now, 26 times 1.5, I believe going to be 39. So 26 times it by 1.5, that's going to be 39. Okay. Equal. On the right-hand side, the 26 will be canceled out with the 26. So you only have the numerators, x minus 200. Now, what you're going to do to solve for x by itself? Okay, so now I'm going to add 200 to both sides. Okay, so we're going to do 39 plus 200 equal x minus 200 plus 200 also. So 29 plus 200 is 239. On the right-hand side, the negative 200, positive 200, they cancel out. So we're going to get the answer is x. So what's the x represent? So that's going to be the minimum score. Yeah. So the minimum score is 239. So in order to be accepted to this school, the student need to score at least 239. Okay. They need to score at least 239. So this is another application of the z-score. So once again, the z-score is going to show data values is how many standard deviation above or below the mean. The z-score show you the number of standard deviation data values is above or below the mean. So this is one of the way that we can show the relative position, the z-score, right? We also have another option that you can show the relative position, which is the percentile. Percentile. So what is a percentile then? So recall that the median divide the lower 50% of a set of data from the upper 50%, right? So the median is the one right in the middle. It separates the lower 50% and the upper 50%. So about 50% of the value will be less than the median, and then about 50% of the observation will be more than the median. Okay. The median is a special case for a general concept called the percentile. So the median is just a special concept for the bigger concept, which is a special case for a bigger concept, which is percentile. So what is a percentile? The kth percentile denoted by P sub k. P sub k. Yeah, so the k percentile of a set of data is a value such that k% of the observation are less than or equal to that values. Yeah, so such that k% of the observation is less than or equal that number. So after you arrange a data in ascending order, percentile divide a set of data is written in ascending orders into 100 equal parts. So we have the smallest, and then we got P1, which is the first percentile. So the first percentile is gonna separate the bottom 1% and the top 99%. Now, similar idea, we got P2, right? So P2 is going to be separate the bottom 2% and the top 98%. Similar idea, we can interpret P3. It separate the lower 3% and the top 97% and etc. So that's going to be the definition for percentile. So let's do an application with the percentile to give you a better idea of percentile. The GRE, or the Graduate Records Examination, is a test required for admission to many U.S. graduate schools. The Universities of Pittsburgh's Graduate School of Public Health require a GRE score no less than the 70 percentile. Okay, no less than the 70 percentile for admission into their Human Genetic MPH or MS program. Interpret this, so we're going to do the interpretation of this admission. No less than the 70%. So the requirements are no less than 70 percentile. Okay, so what does it mean by no less than? No less than. So if you less, they say no, right? So that's what we mean by no less than. So no less than would mean greater than or equal, right? So no less than would mean greater than or equal this, yeah. So I can say that's going to be greater than or equal. Okay, so that's what I mean, yeah, okay. So no less than, which means that's going to be greater than or equal the 70 percentile. So the 70 percentile, what's the meaning of that? The 70 percentile, it separates the bottom 70% and the top 30%, right? So separate the bottom 70% and the top 30%. So it have to be greater than or equal to the 70 percentile. So which means that the student, yeah, so the student need to be in the top 30% to be accepted to the program. So the 70 percentile separate the bottom 70% and the top 30%, right? And then the admission required, that's going to be greater than or equal with the 70%. Yeah, so it have to be greater than or equal to the 70 percentile. So greater than is on the right-hand side. So you have to be on the right-hand side of the 70 percentile. And then on the right-hand side of the 70 percentile is the 30%. So the top 30% of the students will be accepted to this program. They only accept the top 30% of the students. Yeah. So that's what I mean by this interpretation, that concept. Yeah. So that's the meaning of this requirement for admission based on the concept of percentile. Okay, so after we feel comfortable with percentile, now we're gonna do some things related with percentile, which is the quartiles. So when you hear the term quartile, say that's familiar. Quartile, it looks like quarter, right? Okay, so it sounds similar with quarter. So let's see, are they really related? So quartiles are the most common used percentile. Quartile divide the data set into quarters or fourth. So we have the quartiles are the 25 percentile, the 50 percentiles, and the 75 percentile. So that's going to be the quartile, the first quarter, the second quarter, the third quarter, right? And the fourth quarter, yeah. So the quartiles is the 25 percentile, 50 percentile, and then the 75 percentile. So the first quartile is Q1. We're going to use in Q1 to show the first quartile. So the first quartile is the 25 percentile. So the first quartile Q1 separate the bottom 25% and the top 75%. So that's going to be the first quartile. So about 25% of the observation will be less than or equal the values at Q1 or the first quartile. So Q2 is going to be the second quartile or the 50 percentile. So Q2 is going to be the second quartile or the 50 percentile. So for Q2, it's about 50% of the observation will be less than or equal that number. And now we got Q3. So Q3 is going to be the 75 percentile. So Q3 is the 75 percentile. So for the 75 percentile, which means that's about 75% of the observation will be less than or equal to this value. Yeah. So Q1, 75%, Q1, 25 percentile, Q2, 50 percentile, Q3 is going to be 75 percentile. So we divide the entire population, the entire data set into fourth, right? Fourth equal part. So how we're gonna find out the quartile by hand? Theoretically, you might base on the definition to find out the quartile by hand, right? So let's take a look at the procedure then. So step number 1, finding the quartile. You need to arrange the data in increasing orders. Yeah. Step number 2, determine the median M1 or determine the median, the overall median M or the second quartile Q2. Now, step number 3, divide the data set into half. After we got the median, now we're going to get the lower 50% and the top 50%, right? So that's what I mean by half. So divide the data set into half. The observation below the median or to the left of the median, and the observation above the median to the right of the median. In order to find out Q1 or the first quartile, the first quartile Q1 is the median of the bottom half. And the third quartile Q3 is the median of the top half. So that's why you need to find out the overall median Q2 first. So after we got Q2, we separate the data values into the lower half and the upper half. Now we're going to find out the median for the lower half. That's going to be Q1. You're going to find out the median for the upper half. That's going to be Q2. Oh, Q3, sorry. Yeah. And then Q2 is the overall median. Yeah. So if the numbers of observation is odd, do not include the median when determining Q1s and Q3. So if the numbers of observation is odd, do not include the median or Q2 when determining Q1s and Q3 by hand. Okay, so let's give it a try for this concept of the quartile, right? So I'm going to use a calculator to make it easier for me with this calculation. So I'm going to go to edit. I will input the data onto my list. And then ask a calculator to help me arrange it. Yeah. So we have 95, 117, 210, 154, 193, 117, 130, 133, 268, and then 145. Okay. So those are the 10 values that we got. Now, so I'm going to use a calculator to arrange the data in increasing order first, right? So I'm going to go Stat. I'm going to go to the calculation and then to the edit option, and I'm going to use an option number 2, short ascending. I'm going to go down to option number 2, hit the enter key. And then what's the list that you want to do the arrangement? We're going to do list number 1, right? So second key number 1. Okay, the calculator will confirm that they done with arrangement already. They short the ascending for list number 1. Now I'm going to go back to list number 1. So go back to Stat and then go to the Edit option to see list number 1. So now I need to list it out, arrange the data. So we have the first one is 95. The next one is 117. We have 2 of them, 117. 130, 133, 130, 133, 132, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 133, 145, 154, yeah, 145, 154, 193, we got 210, 193, yes, 210, and then 258, 268 right there. So we need to arrange the data in increasing order, right? So that's what we got so far. Now, after we arrange it, now determine the overall median. So the overall median, in this case, the numbers of observation is 10, which is an even number, right? So you can remember how we determine the median, right? So this is the overall median, or this is going to be the answer for Q2. So Q2 is the 50 percentile. So in this case, the numbers of observation is 10. You're going to take the last two in the middle, add them up, and divide it by 2. 1, 2, 3, 4, 5, and 6. Okay, so I'm going to take 133 and 145. I'm going to do 133 plus 145. I will add them up and divide it by 2. So that's going to be my overall median. So 133 plus 145 divided by 2. 139. Okay, so that's gonna be my overall median, or that's gonna be the Q2. Okay. Now we're gonna find out Q1. How we're gonna find out Q1 then? So after we got the overall median, now we're gonna get the lower half. So the first 5 observation will be the lower half. Sorry, let's say 1, 2, 3, 4, 5. Okay. So this is going to be my lower half right here. So this is going to be the lower half. So based on this lower half, I'm going to find out the median. And that's going to be the Q1. So for the lower half, we have the median is 117. So 117 will be my Q1 on the first quartile. So Q1 is equal 117. Okay. Now similar ideas, I'm going to take a look at the top half right here and find the overall median for the top half. And that's going to be the Q3. Okay. So in this case, Q3 is going to be equal 193. Okay. So that's how we determine the Q1, Q2, Q3s by hand. So just in case, if you want to know the interpretation, how we interpret this. So the overall median is Q2, so which is the 50%, right? The 50 percentile. So we can say that's about 50% of the observation will be less than or equal 139. About 50% of the observation will be less than or equal 139. For Q1, we have 117, so we can say that's about 25% of the observation will be less than or equal 117. And Q3 is equal 193, so we can say that's about 75% of the observation is less than or equal to 193. Okay, so that's going to be the interpretation of Q1, Q2, Q3s and how we do it by hand, right? So we actually might use a calculator to get the answer for Q1, Q2, and Q3s, everyone. We have the summaries over here. The one bar start option that we used earlier can help you with the answer for Q1, Q2, Q3. Let's take a look at the calculator then. Okay, so the first step, you have to input the data first, right? So let's double check. Okay, we have all of the data already right here. You don't need to arrange it, just put the original data, that will work. Yeah. So, but in this case, I already arranged it. That's fine. Okay. Now, so I'm gonna use the one bar start option to get the answer for Q1, Q2, and Q3. So I'm gonna go to the stat and I'm gonna go to the calculation and the one bar start option. And then the list that we have is list number 1. And then for this case, we don't have the frequency. So you make sure that we clear, we don't put anything for the frequency. And then we're going to go down to the calculate and wait. Okay. So we got the answer for the mean. We don't need that for this question, right? So we need to get the answer for the Q1, Q2, Q3. So you can say, oh, I see the answer for Q1, 117. That's good. Now, where's the other two answer then? So you can see the arrow down, which means that they have more output down there, right? So just give the going down, the arrow down arrow right here, right? So going down. Now we have the median or Q2 gonna be 139. And when you go down furthermore, we have Q3 is equal 193. So you might do the calculation. You can find out Q1, Q2, Q3 by hand, or you might use the one bar start option to get the answer for Q1, Q2, Q3. One or the other should work, yeah. Okay, so this is gonna be the calculation for this position, right? So we talk about the calculation for the z-scores and the quartile. So I will stop the sharing at this one. This is gonna be the conclusion of the first half of this section. I will see you next time for the next recording.